Hello students, welcome back to my channel. Today I have come with few questions based on gravitation and simple harmonic motion which were asked in the morning shift of 29th January 2023 JEE mains. So without wasting time, let us discuss these questions. So here comes the first question. Two particles of equal mass m move in a circle of radius r under the action of their mutual gravitational attraction. The speed of each particle will be. Now, this is the circle along which the particles are going. So, let us say M and M. These two are the instantaneous positions of the two particles. They have to be diametrically opposite. Okay. Then you have to find the speeds of each. Speeds will be tangential in direction. Okay. And the radius of the circle is R. This much is given. Now we'll be applying the simplest concept which is applied in any circular motion, that is known as the law of circular dynamics, which states that the net force acting towards the center on the particle should provide the required centripetal force for the particle to go along the circle. So here the only force acting on any one of the two particles, you can say, is the gravitational pull exerted by the other. So this should cater to the need of the centripetal force required for a particle to go along the circle. So continuing this, so gravitational pull will be G product of mass upon separation. You can see the separation is 2r, so 2r whole square should be equal to centripetal force. As always, centripetal force, you can always use this formula mv square by r. So one m gets cancelled here and one r gets cancelled. So we are left with Gm by 4r is equal to v square. Therefore, v is under root Gm by 4r. Okay. So fourth option is the correct option. M I have taken capital, doesn't matter. A solid sphere of mass 2 kg is undergoing pure rolling on a horizontal surface with kinetic energy this much. The velocity of center of mass of the sphere is. Now, this is also a simple question based on the total kinetic energy of a rolling body. As you know, a rolling body simultaneously performs two kinds of movement. One is rotational about its axis, and the other, the axis itself undergoes a translatory motion. So, this due to translatory motion, the translatory kinetic energy will be half mv square, and due to the motion, rotatory motion about its own axis, the rotational kinetic energy will be half I omega square. When you add them, you get total kinetic energy. So total kinetic energy is translatory kinetic energy plus rotational kinetic energy. So that is how we calculate half mv square plus half, since it's a solid sphere, the formula for moment of inertia about its diameter is 2 by 5 mr square, and omega can be written as v by r whole square because we have to find the velocity of center of mass. So I am eliminating omega, writing it as v by r. Okay, then r square gets cancelled here, and taking half mv square common, we have 1 plus 2 by 5, that is 7 by 5. 7 by 5. Now here it is given that the kinetic energy is 2240. So let us equate this. Okay, half mass is 2 kg, v square we have to find, and we have 7 by 5. So 2 2 gets cancelled here. 7 3s are 21, 7 2s are 14. Then 320 is equal to, this 5 goes up, 5 can be written as 10 by 2 is equal to v square. So 2 into 160 is So as you can see, V square is equal to 1600. It's a perfect square, students. So this will be 40 meters per second. 40 meters per second is the answer. Moving on to the next question. Surface tension of a soap bubble is 2 into 10 power minus 2 Newton per meter. Surface tension is given, and we have to find the work done to increase the radius from this to this. As you all know, students, whenever there is an increase in the surface area, exposed surface area of a liquid film, work has to be delivered or energy has to be given, because all the molecules lying on the surface has excess energy in comparison to the molecules which lie well within the liquid. Okay, because in order to reach the surface, the molecules need to overcome the forces of attraction of other molecules which are within the liquid. So they have to do work against those forces to reach the surface. So they have excess potential energy. Okay, so that excess potential energy has to be supplied in the form of, some form of energy or other. Now, that excess energy per unit area required is actually surface tension. So, the total work done will be energy required per unit area multiplied by the increase in area. Multiplied by increase in area. Now, energy required per unit area is actually surface tension, is equal to surface tension, and increase in area we have to find. So, this is how you calculate this. Okay. So surface tension is how much? Surface tension is given as 2 into 10 power minus 2 Newton per meter. Now remember, a bubble has two surfaces. One is the inner surface and the other is the outer surface. So we have twice of 4 pi r square. Okay, 4 pi r square. So final radius is capital R, initial radius is small r. So this is how we will be calculating. So 2 into 10 power minus 4 into 4 into, we'll take pi as 22 by 7. So this is 7 square minus 7 and half square centimeter to be converted into meter. Remember, it is square, so 10 power minus 4. Then, so here we have 2 to the 4. This is already 4 to 22 by 7. This will be applying the formula a square minus b square is equal to a minus b into a plus b. So 7 plus 7 by 2 is 21 by 2. 7 minus 7 by 2 is 7 by 2 into 10 to the power. This is minus 4 and this is minus 4. This will be minus. This is minus 2. I'm sorry. This 10 power minus 2. So this will be 10 power minus 6. We expect the answer in SI unit because we have substituted all the quantities in SI unit. Now students, you can see all the options are in 10 power minus 4. So we have to retain 10 power minus 4 and then we have to proceed. So this will be 7 3s are 21, 2 2s are 4. So we are left with 4 into 22 into 3 into 7. Let us divide by 100 and keep the 10 power minus 4 there itself as per the options. So this will be 4 3s are 12 into 22 into 7. So this will be around 110 will take here and another 10 will take it here. Now you can see this around 12 sevens are, we can write 84. So 8.4 into 2.2. 7 into 12, 84 by 10. So you can see, you can take this as somewhere around 8 and this as 2, or 8.5 and 2. So 8 to the 16 or 8.5 to the 17 and all. So somewhere close to 16 or 17. This seems to be the only option which is close to this. So without calculation we have to reach there. Right. Moving on to the next question. Two simple harmonic waves having equal amplitudes of 8 cm and equal frequency of 10 Hz are moving along the same direction. The resultant amplitude is also 80 cm, 8 cm, sorry, the phase difference. You know that during interference, the amplitudes can be added vectorially. This is the shortcut, students. So as per the question, both the vectors which have to be added, their values are 8 cm each, and the resultant is also of 8 centimeter. So that means the vector addition will give you a triangle. So these are the two original uh, what you call vectors which have to be added, and this is the resultant which is also. Since it is an equilateral triangle, each of these angles must be 60 degree. Now we have to find the phase difference between the individual waves. So initially this was like this, and the other wave was like this. You have to draw them as co-initial vectors to get the angle between them. So this is the angle between them. So the required angle is 120 degree. 120 degree is the answer. Remember students, the angle between two vectors can always be found either by drawing them as co-initial vectors, that is starting from the same point, or as co-terminus vectors, that is terminating at the same point. Then you get the smaller angle between them. Always remember, angle between two vectors is always less than or equal to 180 degrees. It cannot go beyond 180 degrees. Moving on to the next question. A person observes two moving trains, A reaching the station and B leaving the station with equal speeds of 30 meters per second each. If both trains emit sounds with frequency 300 Hz, then approximate difference. So a person is standing like this. One train is approaching. Okay. So here the frequency as observed due to this will be FO into, we are assuming that the observer is at rest, is it? So observer is at rest, only source is approaching. So since source is approaching, we have to use this. And here the source, the other source is receding away, receding away. So the frequency as observed here in this case will be F naught V upon V plus Vs, Doppler's effect. So we have to obtain the difference. Difference means larger minus smaller. So we can take this V square minus Vs square into 2Vs. So this is the formula actually. Twice F naught V Vs upon V square minus Vs square. Okay, you can substitute the values and you can get the answer. Then, now suppose in most of the case it happens Vs is too small compared to V. If that be the case, then you can ignore this and you can cancel one V. So to get delta F is equal to twice F naught plus V. Remember this very approximate. Okay. If the options are quite far away from each other, as you can see this, you can always use this. Moreover, you can see 30 is quite small compared to 330. So we'll go with this approximate formula. F naught is 300 Hertz and V is uh, 330. Is it 330? Yes. So 1 0 gets cancelled, 3 ones are, 3 elevens are. So you have 20, sorry, Vs is missing here, I'm sorry. Vs is missing here. So we have twice into 300 upon 330 into 30. Approximate answer. So 1 0 gets cancelled, 3 ones are, 3 elevens are. So we have 600 by 11, which is approximately close to 55 Hertz. So 55 Hertz is the correct answer. Okay, so this way you have to solve. We'll stop here, students. Thank you so much.